All right, welcome to Geometry 8-1. We're learning about tangent lines and circles. And the first thing we're going to do is fill in a definition here. What is a tangent to a circle? So a tangent to a circle is a line. I'm going to write this in purple. It is a line in the plane of the circle that intersects the circle at exactly one point. That intersects, hopefully I have enough room here. I'll do this, the circle at one point. Let me just point out what this is. So, a tangent to a circle. A tangent to a circle is a line in the plane of the circle. So we have a circle and there's a line that's in the plane of it. And it intersects the circle at just one point, in this case, point B. If you imagine that this was a soccer ball and this was a yardstick, a ruler, right? And you held up the yardstick to the soccer ball, it would only touch the soccer ball at one point. And if it touches it, then the line is a tangent. The point of tangency, I'm sure you can imagine, is the point where a circle and the tangent intersect. So in this case, that is point B. So once again, a tangent is a line on the plane of the circle that intersects at one point, and that point is called the point of tangency, the point where the circle and the tangent intersect. Let's move on. Okay, let's look at the first theorem of this section. And what this theorem says, if a line is tangent to a circle, so we know that here's a circle and here's a line, right? Then the line is blank to the radius at the point of tangency. And the answer here is that the line is perpendicular. Meaning it forms a right angle at the point. Each side you could call. Now why is this? Why can't another line form a right angle? Well, let's try to draw another line. I'm going to use green here. Let's say that this line came in like this. It's the same point, right? I actually can't hit the same point. It'll be down here. So you can see that there's only one way for me to draw a tangent that hits exactly at this one point. Even if I get close, I'm going to hit at another point, and if I hit at another point, I'm not going to hit the radius there. I might hit here, or I might hit down here. And all of these lines will have a radius that can come hit it, which we'll explore a little bit later. But, you know, if a line is tangent to a circle, then the line is perpendicular to the radius. So when this radius comes out and hits this one line, you're going to form 90-degree angles. So, knowing that, what's the value of x? Well, again, here are radii of the circle. So here's a radius, and here's a radius, right? We know that these are going to form 90-degree angles here. If that's true, then we can figure out what x is. We just add up these sides, so 90 plus 90. Remember, each of these are 90 degrees. This is 90 degrees. Plus 117 plus x equals 360. Now, since our shape here, LMNO, is a quadrilateral, we know that all the sides add up to 360. So if we simplify this, we'll get to 297 plus the measure of x equals 360. Well, I'll use this, the measure of angle M, same thing as x, equals 63. Just subtract 297 from each side. That's it. So once again, we just said, well, if these are 90 degrees, and we have our third one, we could just, and this whole quadrilateral equals 360 degrees, we could add these together and subtract from 360 to figure out what x must be. Okay, so now we get into an example problem here. In your book, we're on page 764, and what this problem says is that there's a tower, and this tower is total of 400 147 meters. And they give you the equivalency there that it's about 0.45 kilometers, so almost half a kilometer. They also tell you that the Earth's radius is 6,400 kilometers. So we can't see the whole planet here, but if a line went down all the way down to the Earth's radius, to the center of it, right, it would be 6,400 kilometers. So there we are. So the center of the Earth is 6,400. It's all 6,400 from the center of the Earth to this side. Any radius will be the same length. So, knowing that, the question says, how far is it from the top of the tower to the horizon? Now, if we go to the horizon, again, the tangent is going to have one point, and that one point is going to connect to the radius and form a 90-degree angle, right? So, since it forms a 90-degree angle, the triangle that we're going to make is going to be a right triangle, and we could use Pythagorean theorem to solve for this. So the book lays this out pretty nice, but basically you have this side right here we know is 0.45 kilometers, also labeled right here as 0.45. We also know that the radius is 64. So on one side we have this side right here. Excuse me, my pen is. This side right here is the 6,400 plus 0.45 squared, using Pythagorean theorem. And that should be equal to the two legs, because this is our hypotenuse. So one leg is 6,400 squared, and the other leg is what we're trying to find. From the top of the tower, I'll use a different color here. From the top of the tower to Earth. I'm not going to do all this math for you, but if you simplify it and you perform the Pythagorean theorem, you'll end up getting that the measure of this purple side here from the top of the tower to the side of the Earth is going to be about 76 kilometers. All right, let's move on. All right, now we're looking at our next theorem, theorem 12.2, and what that says is if segment AB is perpendicular to OP, to a radius, then, and I'll fill in the rest of this, the line is tangent to the circle. This is basically the reverse of what the first one said. So what this said is, if you have a line, and this line is perpendicular to the radius, then this line is a tangent. So it's just working backwards. Knowing that, then what can we solve? So it says find x. So we know that this line, because this segment here is perpendicular to the radius, it forms, because it forms a 90-degree angle, it's tangent to the circle. So again, we could use Pythagorean theorem to solve here. So our two legs, one leg is x squared, plus our other leg, which is 12 squared, equals our third leg, which is x plus 8 squared. So once again, we'll have x squared plus 144 equals, and we could x plus 8. That's going to give us x squared plus 16x plus 64. Let me use a different color here. Subtract x squared from each side, and I have 144 equals 16x plus 64 minus 64 from both sides. And I have 16x equals 80. Divide by 16, and I get x equals 5. Pretty simple. Let's move on to one more question. What this one says is it's given us all the three sides of the triangle. So one side of our triangle is 25, one side is 24, and one side is 7. And this question says, is ML a tangent? So is ML a tangent? It's asking us, I'm going to draw this in color, if this is 90-degree angles, right, then This is a tangent because it would hit the radius at 90 degrees. So how can I prove that this is 90 degrees? Well, if the Pythagorean theorem is true for this triangle, if 7 squared, if the legs squared, the sum of the legs squared, add to the hypotenuse squared, then this is a right triangle. So we just need to see if that's true. So is 7 squared plus 24 squared equal to 25 squared? If that is, that means that this is a right triangle. And if it's a right triangle, that means that LM is perpendicular to NL, which is what the question is asking us. Is it tangent? 7 squared is 49. 24 squared is 576. 25 squared is 625. And 49 plus 526 is also 625. So guess what? Let me just run through this logic again. Because this is true, that means that this is a right triangle. Because this is a right triangle, it means that LM and NL meet at a right angle. And because that's true, we know that this is a tangent. Theorem 12.3. If two tangent segments to a circle share a common endpoint outside the circle, then the two segments are, and I'll write this in, congruent. So if A, B, and CB share a common endpoint, then these two are congruent lengths. Knowing that, what can we say? Well, that means that, let's say if A to, I didn't label all the points here. I think this is D, E, F. If AD is 10, and it's a tangent, guess what? Then also AF is going to be the same length of 10. If DB is 15, so is EB going to be 15 centimeters. If FE is 8, then CE is also going to be 8 centimeters. So if the question is, what is the perimeter, I could just add these up. 15 and 15 make 30. 10 and 10 make another 20. And 8 and 8 make 16. Altogether, you would have 66 centimeters is the perimeter. Okay, hopefully you could apply these ideas in your work, and I'll catch you on the next time. Thanks, bye.